Dzień dobry Państwu, nazywam się Piotr Mitas i witam na forum eDPS. Zapraszam na wywiad z Jeremym Drew, przedstawicielem firmy Markforged, odpowiedzialnym za zespoły inżynierskie w Europie, Bliskim Wschodzie i Afryce. Porozmawiamy sobie o zastosowaniu drukarek 3D firmy Markforged w różnych firmach. Wywiad ten nagrałem kilka dni temu ze względu na dostępność mojego kolegi.
Hello everyone and welcome to this discussion about using 3D printing in various businesses. My name is Piotr Mitas and I am the coordinator of the 3D printing department in DPS software. And I would like to welcome my guest, Jeremy Drew, who works in Markforged and is the applications engineering manager in EMEA, which stands for Europe, Middle East and Africa. Jeremy, thank you for finding the time for this interview.
Really appreciate being invited. Thank you so much. Looking forward to it.
Now, Jeremy, can you please tell me how much experience do you have in additive technologies in general?
Sure, by all means. Well, welcome everybody. I'm 55 years old now, so I've had sort of good 35 to 40 years in engineering. Typically in subtractive engineering. That's really my background. My father was a tool maker. So with regards to additive, I was involved with additive over like 20 years, effectively on the receiving end, looking at how additive was going to be used in industry. And for many, many years, additive was oversold and underdelivered. And I watched it from a distance and had basically a view on it. But within the last few years, obviously, additive has become a lot more important into industrial applications. And I was approached by Greg Mark, who's the founding executive for Markforged, who said, would you like to come to work for Markforged? And I sort of looked at the opportunity and thought, well, let's just see what the options are. And when I saw what the technology was all about, that is basically what attracted me to join Markforged. So to answer your question, I've had 2 years directly with Markforged, but 20 odd years looking at the additive world and seeing how it integrates into the more conventional manufacturing industry that we actually know and love.
Okay, well, that's a lot of experience. From your experience, can you tell me what are the most common misbeliefs of people about 3D printing?
Yeah, I think it's a fascinating story. If you look at it over the last 10 or 20 years, additive manufacturing has always been the idea, the big white hope, the one which basically is going to allow us to take technology to the next level. And, you know, generally the idea of having 3D printers in everybody's home seemed like a pretty interesting idea. Obviously, people like Amazon and others would actually then have a bit of an issue with their business model if that were a success. But the reality of additive is that although it is a unique technology, until the materials are at such a stage that they become industry relevant, the actual technology itself has limited impact. So what I mean by that is that people have been using additive to create parts that actually look like and feel like a product. So for example, in the world of rapid prototyping, additive has been used for 10 or 15 years now to give you a part which resembles the part that you're actually going to get. But there is a disconnect between that and actually how you're going to be producing the part in the industrial world. So for enabling CAD designers and CAD engineers to be able to actually then showcase their technology, additive has been quite useful. But really, I think from an industrial perspective, it's been perceived as a way of creating something that looks like and sort of feels like, but doesn't work like. So it can't actually be used in the end application. So for us, we see the idea of additive as being purely a way to showcase a CAD model in a three-dimensional representation. And for many years, that's where it sat. But now with the onset of new materials and new materials developments, and including things like, for example, 3D printing of metal, suddenly the whole technology is starting to spin toward a much more industry relevant area. And this is the reason why I found this most interesting and why I came across to the other side and actually looking at additive in a different world, because suddenly you have a part which is carbon fiber reinforced with a metal component on it as well. Now that part not just becomes a looks like and feels like, but it actually becomes relevant to the industry, which means that you can actually put this in an application on a production line and allow it to work. And from that, then the relevancy of the technology suddenly then goes up a notch and then becomes effectively equivalent to buying a CNC lathe system or maybe some form of conventional subtractive technology. So really it's the way that additive is now grown up, is now become very, very important to supplement some of the issues that we have in the subtractive world. So in answer to your question, up until now, I think additive has been seen as a way of being able to create toys, parts which look like and feel like, but don't actually work. Now, the additive space is moving into the area of saying it looks like, it feels like, and it works like. And that is the relevancy. And I think why your industry and why the Polish industry specifically is looking very much at this area, because it gives you a certain level of flexibility that in common supply chains that you'd have through the more conventional ways, it rethinks and reimagines how we can do things. So the reason why I've been brought in is to try and bridge the gap between industry where we are currently and where industry could be by deploying additive.
Okay, so the whole process of maturing additive technologies, it's mostly materials, right? It's the materials that we can actually use during printing to make the parts not only look like real parts, but actually become real parts, thanks to the engineering materials that we can use, right?
To a point, yes. I mean, obviously materials on their own actually is probably one of the most fundamental shifts towards making it industry relevant. But the ability, for example, for the software to come together with the hardware, for us to be able to actually then print locally at the point of need. Now, you know, obviously the issue with regards to COVID, I think was an interesting example actually where additive can really break the normal supply route and alter things. So for example, rather than buying from the Far East in high volume, suddenly you're able to produce parts like this where basically for the visors for COVID safe situations. And people could actually leverage their printers to actually do some work in this area. Now, sometimes the materials aren't the main driver here. Maybe in this particular important area, it's actually the way that we could actually print locally at the point of need and supporting your local hospitals literally from your home office. So for us, what we're seeing is it's a combination of clearly having the right materials that are durable, industry relevant, but also the software. And Markforged calls this the digital forge, which is a way of being able to wrap the hardware and the software together and printing literally across the internet. So for us, it's ability to actually be able to do these sorts of things as well. So to answer your question, yes, materials are probably the most important part, because without the material, the relevancy falls apart. But then the next stage after that is actually not just replacing current parts, but actually being able to print them at the point where you actually need them. So if you're a business, for example, where you're actually exporting your products, the ability to actually print spare parts in a different country to where you manufacture your baseline unit is definitely a completely different industry, almost game-changing way of actually being able to look at additive. It's a completely different mindset, and it's something that basically we get really, really involved with, and why I guess, you know, our technology hopefully will be relevant for the markets that actually you and the team are obviously working on at this moment.
Okay, so let's catch on to the idea of actually printing things locally. Like you mentioned, the COVID situation right now and printing the visors. So on that topic, can you just explain a bit more? What are the strongest and most common in the companies that you had to deal with while working at Markforged benefits of actually having printers in-house, except for, helping the local community, that's one thing, but speaking of purely business-like approach.
Okay. Well, I mean, there's a couple of things, obviously, with regards to let's talk about the negatives, right? Let's talk about the reality. And I would rather talk at it from a negative perspective, because having the bulk of my career looking at additive from the outside, it's very interesting to actually try and balance the overall view. Typically, to injection mold a part like this would take maybe a matter of minutes, whereas to actually print a part like this could be a matter of a few hours. So from a conventional manufacturing standpoint, you probably wouldn't want to print it over actually being able to injection mold the part. But if your injection mold tool costs 100,000 euros, if you want to do a modification to this particular part or change it to fit your profile of a head, or basically change the functional form, you can basically do this very, very easily without investing in any tooling. Now, suddenly, in the world of conventional manufacturing, if you remove the 100,000 euro barrier to entry, suddenly you're in a situation whereby if you are able to print these and be able to print them bespoke and different every time, you could print 100,000 of these literally at a very cost-effective solution without having to have that barrier to entry. So suddenly the opportunity for companies who were not involved with the national health services around Europe were in a situation whereby they were able to print these parts purely because we actually shared all the files, and suddenly across the whole of Europe, people were actually able to print these parts at a cost-effective manner at the point of need, which for us meant that we actually had hundreds of thousands of these actually out in the field working with doctors and nurses. So for us, we felt that the deployment of the technology was very much a case of being able to leverage the ability to print in what we call print farms actually around Europe to actually be able to leverage the resources that were necessary. So for us, I think the materials aspect of this, we were actually using carbon fiber reinforced parts. So what we were doing here is basically providing solutions into the industry, which basically meant that they were more robust, they were stronger, they were lasting longer. And so therefore, suddenly you again got the next stage, which is actually the ability for the material to outperform convention. So actually, if you link together the flexibility without tools to actually be able to produce this part from scratch. So literally, you have your CAD file and you print. If you want to do a modification, you modify the CAD file and then print, rather than having to go through any changes in tooling. You're in a situation whereby it becomes a fully flexible operation. So what you could be doing is printing 100 visors one day, and on the next day, you could actually be printing tooling jigs and fixtures for manufacturing locations and other things around the world. So suddenly the flexibility in being able to, rather than having to productionize and produce 100,000 of something, you could produce exactly what you needed. So suddenly the inventory cost drops out as well. So having a harder wearing material, having the full flexibility without tooling up front, which is obviously very, very helpful, and the ability to actually then change your workflow according to the need at that particular time meant that you actually then had full flexibility in your supply chain. And for us, when you start to realize the potential of how that can actually change your business, then the value of additives suddenly becomes much more credible in the market.
Okay, so yeah, flexibility is definitely something that no other tool or machine, I mean, gives you more flexibility than a 3D printer. Sure. Like you said, you can print 10 or 50 iterations of the same part, slight changes, see which one is the best, or maybe 50 because you have 50 different needs for a part to work at, and they all had to be slightly changed, right?
Absolutely. I mean, just to give you an indication, I mean, this particular tool here, if you look at the serrations on the inside, this is a tool which is basically designed, it's a bit like with your alloy wheels on your car, where you have a special tool which basically stops people from, it's an anti-theft device. Well, this is very similar. So this feature here is actually just a standard cross-section which basically can be torqued up. So having these particular items actually able to be printed with small iterations and modifications, rather than having to create a tool to create the part, you just create the part.
Of course.
And therefore the toolingless production, if you look at the cost per part, it might be more expensive, but if you take out the cost element for the tooling and the ability then to actually then iterate and change every day your workflow according to the needs of your business at that moment, it sort of opens up a completely new door to a lot of senior executives. And what we're trying to do is basically try and expand upon that, saying our additive technology is good. There are other technologies out there, but in principle, additive is a way of being able to revolutionize your business. And by the correct choice of the technology, you can effectively then use that to take new markets, new opportunities, new ways of doing things. And also, I think for your business, actually adding additional value to your workforce, because also your workforce will become much more creative rather than living with the limits of having to bend or twist or create some changes to tooling which isn't quite right. You actually just print what is really right. And then suddenly you're in a situation whereby you get a team which goes, wow, actually all of these preconceptions that we were working on before, we don't have to do anymore. We got involved with a very large automotive company that was actually involved with manufacturing vehicles. And they, on their paint shop, they had spray heads. Now these spray heads were like a swan neck. And these swan necks basically were operating in synchronous with effectively a series of robotic arms to ensure you have good coverage for paint over the vehicle itself. And each of these needed to be twisted and bent to according to the vehicle. And as a consequence, the setting time on the line was 40 minutes, 40 minutes. Now, if you have a line stop for 40 minutes in a production plant for cars, it's costing you a lot of money. Imagine now printing the exact part that you need, every time getting it right with regards to the actual location of where it needs to be, connecting up the part and hitting the go button on the line. We reduced the line downtime to literally 2 minutes, saving 38 minutes with regards to effectively setting time and therefore line stop. So on a cost by cost basis, our part was more expensive. But the culmination of changing those parts 10 or 20 times within a period of 1 month meant that the amount of line stoppages were reduced significantly. And as a consequence, the throughput on the line is so much greater, and therefore the output from the process is actually significantly higher. And it's these small nuances which often get taken for granted, that this is the way it's always been. If you can reimagine how it's always been and then take it to the next level and say, actually, it doesn't have to be like that anymore, it suddenly then just creates a discussion point, which we find revolutionary. And we hope also that you and your team and the rest of the team will understand that this for us is a passion. It's not just a technology, it's actually a way of life almost. And, you know, we're not evangelizing about it, but at the same time, it is just a different way of being able to think and breathe.
Okay, so I mean, creating those parts to actually reduce the downtime and reduce the time that the line had to be stopped, that was a challenge, right? So can you just tell me a bit more? What other challenges you had to face with customers that wanted a 3D printer, and you know, customers that really were expecting a lot from their prints?
Okay. Well, we can certainly go through a few examples today. What I would refer you back to is actually on our website. We have a lot of use cases where we basically have gone through specific areas from the medical industry to aerospace to automotive. And as an action maybe from this discussion, what we can do is share with you what we call our 100 ways opportunity, which is actually looking at 100 different applications where we've actually then made a difference, because each time your own specific need will be different. So in this particular example, this was a company called Black & Decker. This was actually an item which was actually 5 or 6 components, which was brought together into one printed component. Now, there was a few steps in between with regards to where we were with this from the original design. So there is actually some engineering time that needs to be spent. So you'll see some of the holes, for example, actually have certain features in there. And those features are a little bit unusual with regards to how you would conventionally manufacture this part. But what this part has proven actually over time is by condensing 5 or 6 components into one, the actual lifetime and life expectancy of this part because of failure is now actually longer than the original. So as a consequence, by moving to additive, not only have we actually managed to become cost neutral with regards to the part itself, but we've actually increased the life expectancy of the part in the field. So as a consequence, the downstream returns and the failures that have been seen in field have significantly reduced. Now that is a significant cost saving, but generally was only seen maybe 2 to 3 years after we actually did the initial investment. So we've actually, this one's been kicking around for us at about 3 or 4 years with us now, but we're actually showing this purely on the basis that from our side of things, this is a really good way of being able to showcase not only can you actually be cost effective on a part by part basis, but also effectively cost effective downstream with regards to returns and other issues in the business. So this is a metal example actually in effectively a standard 17-4 stainless steel material, but this could also be in tool steel. And we also have now printed copper, which we've got some really nice examples actually how copper is being used. And for composite, you'll see basically here in this particular design, I don't know whether you can see that okay, but in essence, this is an assembly. So rather than printing this in one part, we actually printed this part actually in several components. We've got the 2 upper and lower plates, and then effectively had the separating bars in between, and then used a series of conventional screws and bolts, or nuts and bolts, to actually bring this part together. Now, as a consequence, the part itself has a high level of rigidity. And as a consequence, this basically has replaced several other parts in their design. And this is one example of probably 100 in this particular client case where we've managed to lightweight and increase stiffness. So for example, in this is an area where on a robotic arm, when a robotic arm moves from one position to another, there is a certain mass that robotic arm is carrying. If you reduce the mass that's being carried by the robotic arm, you're in a situation whereby you can move the robotic arm quicker, which means you can increase the line speed. And increasing a line speed by 1 or 2 seconds, or improving the line speed by 1 or 2 seconds across a total production of maybe 10 to 15 minutes is a significant percentage. And it's finding these little niches and these little opportunities, which often have a fairly insignificant view from the front end. But if you can actually go through the process and engage an application engineer who's really familiar with additive, so someone like yourself, Peter, who basically has been involved with the additive world for many, many years, for us, this is a great way of being able to showcase how you would take a technology, redesign it, make it appropriate for additive, what we call design for additive manufacturing, redeploy that back into the application, and then suddenly find the cost savings start to rocket. And as a consequence, the value add is not just on the unit cost, but it's actually on the benefits of actually using that technology in that area. So we've got loads of applications for composite materials, which is obviously the carbon fiber reinforced materials that we have here, which are ultra lightweighted. But equally, we have many, many examples with regards to what we do in the area of actually metal components. And you'll see here, for example, that these particular items were actually printed on 2 separate printers. And you can probably see, if I can get that close enough to the screen, there's a thread pattern actually on that particular design. There's a thread pattern on this, and literally the 2 are brought together. Now, these parts basically are very tiny, but you can get an indication that actually that for real world end use parts, there's also a space for this particular technology. And very, very quickly, we find, for example, our production rates are lower generally than convention, because why would we think after 100 years of engineering that we can step in and basically take over the world? That's just not what we're here to do. Where we find this is, for example, if you're looking to do a change, you would probably use additive in the front end. So basically you'd redeploy the technology at the early stage development to test an iteration, and then to probably print 2 or 3 parts. Then you probably would want to actually then go for the idea of actually printing what we call bridging production. So before you actually invest in tooling, you might want to print off maybe 100 or 1,000 of these parts. Then by the time that basically you've got the revenue coming in from those 1,000 parts, then you can tool up for it, and then additive drops away. And then over a period of 10 years, you carry on doing it the conventional way. But then what happens after 10 years when you actually lose the tooling and you actually then want to replace this part, what we call legacy parts? Where we're finding the space for additive at the moment is actually in supporting legacy products. So if you've got a lifetime expectancy of 10 or 20 years with regards to your products, you might have to carry a significant amount of stock to support failures in field. Now,
just spare parts, right?
Yeah, exactly. And imagine if those spare parts, rather than actually being physically sat on your shelf, were actually housed in a digital library inside your computer. You're in a situation whereby you can actually access those CAD files, print those CAD files, and print the part when it's needed. So rather than holding 10,000 parts in stock, you can actually have those 10,000 parts all in a digital library costing you nothing. And often in business, for example, especially in the automotive industry, we've stripped out one particular warehouse where we say 350,000 euros just by removing the stock. It paid for the machine 3 times over. And as a consequence of that, basically now they're deploying additive in other areas. So for us, it's a case of we enter businesses at different areas at different times for different reasons. And we have to be adapted to understand what your pain points are so that we can actually then fit our technology to the best area possible.
And so, like you said, first of all, you need to be able to create a part for additive manufacturing, because designing for additive is a bit different than designing for subtractive manufacturing. Sometimes you take 3 parts and you join them into one. Sometimes you take 1 part and you split it into 3, right? Depending on the situation, but still you can benefit from using this technology. And sometimes you print the same parts that are currently available, but you don't want to keep your stock, right? You want to get rid of your stock. You don't want to have your money frozen somewhere in a warehouse, just laying around. You just have a digital library of parts, right? That's fantastic.
Absolutely. Just very briefly, this is a component which basically was quite unusual. This part basically is a component for a seat, for the base of a seat. And you can see actually the complexity in that particular design. I think one of the things I'd like to share with you is actually what I struggle with and where I think education is a huge part of this, whether it be our technology or anybody else's. Additive requires a different way to think. Normally, if you were thinking about manufacturing that conventionally, you'd probably take a block of material and take a milling cutter, mill out all of these features. So you'd have to orient the part, you'd have to do this, that, and the other, and you would probably end up with a weight which was maybe 20% of the original material. So in this,
a lot of material lost on the way.
Absolutely. Now in additive, what happens is basically you take the part and you reconstruct it layer by layer by layer. And by effectively creating layers, you can actually then build only the material that's needed. And one of the things that we struggle with, I think, with regards to trying to get across into industry is that, yeah, you might be able to make this part from solid and you might be able to do it in maybe 50% of the time that it would take to print it. But the reality is that the losses that you have actually with regards to material, which is scrap, so as 80% of the material is scrapped, suddenly you're in a situation whereby you have skilled labor. You have to orient the part at least 2 or 3 times to ensure that you can get the correct application for the actual tool head and the tool path to come through. Suddenly you have a skilled operator taken up for maybe multiple hours in a day just machining this part. With a 3D printer, once you've got the CAD design done, you can actually at 5 o'clock in the evening press print and go home. And then basically the part prints overnight and then the following morning it comes back. It's what we call lights out manufacturing. It doesn't need any skilled operator to operate the machines. So as a consequence, de-skilling the operation, being able to actually then utilize what is already available there, which is time overnight, which you might not be deploying and utilizing elsewhere, suddenly means that you'll have this part available the following morning. So whether it's a 4-hour time manufacturing for conventional, or whether it's a 12-hour print time, just think about the way that you can actually use that time more effectively and the ability to actually print overnight, come in the following morning, test it, it's not right, you redesign, hit go, the following day you get another part. And within 5 days, you can do 5 iterations. So effectively, you're then in a position whereby you can then decide, do I actually conventionally manufacture this, or do I actually 3D print it and continue to 3D print it? And for us, that is the discussion that we love to have, because it's always those nuances that are really, really crucial to understand in business.
Okay. I mean, the possibility to create a part overnight and not to worry that something will go wrong, that you'll have like a collision between your tool and, for example, the bed of your CNC mill. Yeah. That's fantastic. So speaking of fantastic, do you recall any fantastic, awesome moments that you had with your customers after they've started using your printers, or maybe some customers like really, opened their eyes after testing the prints that you prepared for them as samples?
Yeah, it's an interesting one, actually. I guess I'm too old and too ugly to basically, sort of be wanting, other outcomes other than one thing. And that's that light bulb moment. You know, when you see somebody's face and it's like, wow, really? When you get those moments, and in this job, I get it. And I'm very, very fortunate because I actually work with a team of specialist engineers that are part of my team. I'm privileged to work with some amazing engineers. And I've met some amazing, amazing people out there. We work with the top tier automotive manufacturers right the way through to aerospace. And every time it's the case of it's slightly different. And it's being able to redeploy the technology appropriate for that particular client, making them the center of everything. And I think for us, as I said, when you get things like this, for example, they'll say, oh, well, we printed the part and basically we printed it in carbon fiber, but the tips kept wearing out. So you turn around and say, well, okay, why don't we actually design this so basically the tip is in metal and basically the rest of the particular product is actually in carbon fiber? And suddenly making this hybrid design, it's like, wow, can you really do that? Yeah, okay, let's do it this way. Let's try this. Let's do, and we probably have, I don't know, probably every day, at least one of those moments. And when that happens, it feels phenomenal. And I think from an engineer to an engineer, and hopefully to some of the people out that are listening to this, that's a great feeling when you feel like you've changed somebody's view on life, how that is conventionally done and how it can be done differently. And seeing that light bulb moment that you get, I mean, in the automotive world, as I said, probably the biggest area we've had impact on is actually in copper, where we're actually doing weld location pins. And effectively with regards to effectively welding shanks, for example, ultra light weighting in copper. This is a material that's basically being deployed in this area for the first time. It feels a little bit like we're breaking new ground, and it's such a great feeling. We have products basically flying into outer space. We have products basically traveling along trains and boats and in all these different areas. But do you know what? Some of the best opportunities that we've had are with engineering companies, small to medium-sized enterprises. We had one, for example, which we can share with you, which is actually in our library of what we call additive manufacturing movement. It's called 100 Ways, and you have to see this because it's fantastic. We didn't realize this, but our material, which is basically a nylon 6 and a chopped strand carbon fiber, we call it onyx, has what we call neutral buoyancy, which basically in English, in simple terms, means if you drop it into water, it neither sinks nor floats. It stays where it is. Now, that doesn't seem particularly interesting, but actually, if you're a diver and you're working subsea, it's phenomenal. Now, this is a really small application, but I love it because what happens is if you have a diver and if they have a connection to the surface, to the boat, they have what we call a reel, and the reel contains a spool of material which basically allows them to ensure that if there's a problem, they pull on the reel and effectively they then get access back to the support vessel. These things are neutral buoyancy, so they just sit there in water. So what they can do is actually start doing stuff and leave the spool to float, and it stays next to them. Now, we didn't see that as a prime requirement for our onyx material, but this is the sort of thing that if we get involved with engineers out there, we get a phenomenal feedback from you guys. And the more that you're teaching us, the more that we're getting better at actually being able to make additive fit for you. So I don't know if that sort of answers that question, but we've seen these moments where effectively they could be as stupid and simple as just neutral buoyancy right the way through to saving millions of dollars. And I think somewhere in between there is the truth for many of our clients out there, many people who are actually unsure as to whether to deploy additive. My team has a requirement. When we go in and talk to a client, we don't try and sell a printer. We actually look at what the opportunities are out there to see whether we can justify to ourselves whether a printer is actually suitable for your world. And if there is no hard ROI, what we class as a return on investment case, then probably at this stage, we might say you might not be ready for additive just yet, or we might be looking in the wrong area. And I think we'll be honest and truthful with you if that actually happens. But more times than not, we can see different areas. One last little thing I might throw at you. We were involved with a company which is manufacturing packaging equipment. This packaging equipment basically was automated and it was built out of aluminium. And they were exporting these systems around the world. They exported a system from the UK, for example, actually down to Brazil. The system got deployed. As they hit the go button, the system crashed, breaking one part. This company has spent hundreds of thousands of euros on this packaging equipment and it's not running. They're not happy. The normal workflow is that basically this company basically then went back to the UK manufacturer and say, we need this part. This part is manufactured in Germany. The part gets manufactured in Germany, it gets brought into the UK, it's wrong. It goes back, it gets remachined, it comes back. By the time that part got back down to Brazil, it was 6 weeks later. The company has now said that they're going to be selling our technology for us, so that basically when they deploy a packaging machine, they'll actually deploy a printer, because we can print 30% of the spare parts locally at the point of need. So effectively, if there's a spare part requirement in Brazil now, they can print it locally. So what we found is our technology is supplementing the manufacturing supply chain. It's got nothing to do with the cost on the per part. It means that basically they can print parts and actually have that equipment up and running within 3 to 6 hours. So as a consequence, it's a way of being able to make their system more robust. Now that was their light bulb moment. And that was actually what they got across the line to be able to say that additive is right for us. We never thought that would be the case, but by investigating it and by working with the client, we realized that that was the weakness in his supply chain. And as a consequence of that, basically within his business model as a whole. And that's why we elevated the discussion to the CEO. The CEO said, yeah, let's go with this. And that's effectively now what's happening. So these are the sorts of scenarios which basically we're trying to engage, because additive might not be right for everybody. There's often a space which you would not imagine within your overall route where effectively this technology will sit.
Well, from this whole situation with that manufacturer and that broken part and the machine sitting and doing nothing for 6 weeks, I mean, if somebody does not have a light bulb shining above its head when they actually change 6 weeks to 6 hours or a day, maybe even, right? If they don't have a light bulb after that, I mean, that's just the perfect example of how additive can actually help in your business.
Yeah, and it's an interesting one, because for us, I would say, Peter, that we as a company, we're not inventing these opportunities. They're actually out there. It's just the fact they've never been thought that way around. You know, generally what's happened is if you have a problem in Brazil and you're exporting to that country, you might find a third-party engineering company that might be able to support it locally in Brazil. What then happens is you then have modifications to your original design, which basically means you're supplying equipment out around the world. And every time it breaks down, it's changing, which makes your business as an OEM even more complicated, because actually modifications to all these machines around the world. Imagine now the ability to actually cascade a fixed upgrade. So let's say, for example, in Sweden, you actually had a unit which actually had an improvement by doing something. Imagine this. You can now cascade that improvement across your whole supply chain instantaneously by effectively operating and deploying that benefit across everything. Now imagine trying to do that in the real world, you know, through conventional, you know, UPS or whatever else, or getting parts consolidated and built. It just changes the way we think about things. And I think for us, you know, this whole opportunity to engage with you and your team, and obviously the people that are obviously watching this, you know, for us, it's really, really crucial to say, look, you know, we're an engineering company. We just happen to make printers. And we happen to look at it in the way that you look at it. And we wouldn't want to sell you a printer if there is no real benefit for you to have it. What we want to try and do is prove a benefit. And it's a case of looking not just at the, can you print this, but actually, why would you print that? And does that make sense for your business? And how can we actually say, rather than just printing that widget, that little thing, that little part, let's look at how your business operates and let's see whether additive can make a real change, because those are tangible profit and loss situations for us. And that's where we get most resonance. And that's where I guess why we're in the position we're in at the moment, which is one of the fastest growing companies actually on the planet with regards to 3D printing.
Okay, well, all the things you said were really great. Thank you very much for for this whole interview. So unfortunately, that is all the time we have for today. I know that you're busy as well. So thank you very much again for your time, for sharing all the stories and showing us the things you have in your hands, the parts, telling us about them and how you can actually use additive and use Markforged printers to actually make your business easier or just make it work, right? So thank you again, and hopefully we will see each other somewhere, sometime during additive manufacturing.
As you say, post-COVID, whenever that might be.
Whatever that might be.
Keep safe, everybody. And as I said, from my side, it's been an absolute true pleasure. Thank you so much for your time today. Take care.
Take care. Bye.
Wow. Jeremy, dziękuję Ci jeszcze raz za rozmowę. Zapraszam za chwilę na techniczny panel, w którym przedstawię Państwu wszystkie systemy druku firmy Markforged.